mathematicians. So we're in 2.6 continuity. And in this video, we're going to talk about a couple continuity rules. And then we're going to talk about limits of composite functions. And so first, continuity rules. Assuming f and g are continuous at A, then the following are also continuous at A. Okay, so you have two functions, f and g. They're continuous. Then what do you also know? You know f plus g is continuous. You know c times f is continuous. You know f divided by g is continuous, provided g of A doesn't equal 0. You know that f minus g is continuous. You know f times g is continuous, EF. And you know that either of those functions to some power is also continuous. Okay, so you know all of these things are true. You also know that, let's put a star here, a polynomial function is continuous everywhere. Okay, polynomials are continuous from negative infinity to infinity for all reals. Okay, we also know a rational function of the form P over Q is continuous for all x such that Q of x does not equal 0. Okay, so let's take these rules and look at the continuity of a couple things. So let's go ahead and look at f of x equals x over x squared minus 7x plus 12. And the question is this continuous? We have a rational function, so it's going to be continuous everywhere the denominator does not equal 0. Where does the denominator equal 0? Where does that equal 0? At x equals 4 and x equals 3. Therefore, f of x is continuous except at x equals 4 and 3. Okay. Let's see. Another one. No, let's go ahead and go on to composite functions. So composite functions is when you do something like the f of the g of something, right? You're taking this function and you're plugging it into that function. So let's just go over composite functions real quick. Composite functions, just as a reminder. So suppose we have f equals x squared, f of x, and my g of x equals, I don't know, x divided by 4 to the 5th. My f of g of x would equal x over 4 to the 5th squared, because I would take this g of x and I would stick it inside this function. Okay, that's what we're talking about when we're talking about composite functions. And so the rule for composite functions says that if g is continuous at a and f is continuous at a, then f of g of x is continuous at a. You'll also see it written as f composite g, compose g is continuous at a. And this isn't a 0, it's like it's like a really small circle. Okay, another thing we need to write down about composite functions is that the limit, as x approaches a, of f of g of x equals the f of the limit of g of x as x approaches a. Okay, so this is limit of composites. So let's go ahead and use that on a couple examples. So we have the limit as x goes to -1 of the square root of 2x squared minus 1. And they're saying that the inner function is the 2x squared minus 1, and that the outer function would be that to the 1/2. And so if we go ahead and plug this in, though, we actually don't have to really use any rules or think too hard, because there's no problems here. As soon as I plug this in, I get the limit as x goes to -1, 2 times -1 squared minus 1. That is going to equal 1. Okay, so this is one of your examples, but I don't even think you need the composite rules to do it. Let's look at another example. We have the limit x goes to 2 of cosine of x squared minus 4 over x minus 2. And so here they're saying our g of x is cosine x, and they're saying your f of x equals x squared minus 4 over x minus 2. And so this is the g of f of x. That's this composite function here. And so what they're telling you is that you can go ahead and do the cosine of the limit. You can separate this like this if you want. And then you obtain x plus 2, x minus 2. This is a difference of 2 squares up here, right? X minus 2, cancel, cancel. You end up with the cosine of 4. Okay? And so if we were to plug that in our calculator, it would be about -0.654. Okay, so that is continuity and limits with composites. Just some general rules that allow us to do the things we need to do.